Good morning, students. Myself, Vijay Shankar from AC Department, Chippewa Engineering College. Today, we are going to discuss about the magnetic field intensity due to the infinite line charge. In the last class, we discussed about the magnetic field intensity in line charge, magnetic field intensity in surface charge, magnetic field intensity in volume charge by using the Biot-Savart's law. Okay. Now you go for the another topic, the magnetic field intensity due to the infinite line charge. Magnetic field intensity due to the infinite line charge. See the magnetic field intensity H bar due to the infinite line charge is a long straight conductor. Is a z-axis we can assume. On that z-axis, a small differential length we can assume. A small differential length dl bar. That is a 0.1. And on the y-axis, assume a point P with a distance of r, and it is in the direction of AR bar, where you have to find out the magnetic field intensity H bar is a point, and you have to find the magnetic field intensity in this direction H bar, or it is a B bar also, magnetic flux density. And the point 1 from the origin, the distance is z. It is along the z-axis. It is a z into az bar. We have the two components to find the distance of r bar also. Z into az bar is a positive direction. R into ar bar is also the positive direction. Because it is a long straight conductor, the current passes through this conductor. A magnetic field is surrounding the current carrying conductor. Is a current I is also close, so it is a I into dl bar. The point what we are assuming dl bar, because it is a conductor carrying the current I dl bar is at the point 1, and you have to find the direction is AR12 bar. You know the H bar is equal to, due to the line charge, I into dl bar dash AR bar by 4 pi into R bar. Okay, and this becomes of the K into AR bar, or not the K into K bar cross AR bar into ds, and it's j bar cross AR bar into dv in the numerator multiplied. It is into dv is a surface integral h bar, and the h bar is equal to the volume integral. This is a volume integral, and this one is a surface integral, and this one is for the line integral. So we are assuming consider an infinite line straight conductor along the z-axis. The current is passing through the conductor. Is a direct current of I. The field intensity H bar at a point P is to be calculated, which is at a distance of r from the z-axis. Consider a small differential element dl bar at point 1 along the z-axis. At the distance z from the origin, I dl bar is equal to because it is on the z-axis. dl bar is a small differential z dz along the z-axis. So I dz az bar, differential length DL bar is equal to, it is on the Z axis, so the dz into AZ bar. Got it, my students? So assume a right angle triangle like this. With here the point P, here the point P is there. To find the magnetic field intensity at the point P, you get the downward direction of Z into AZ bar and the positive y direction, nothing but is a PR bar. So minus Z AZ bar and the R into AR bar, and towards that is a point Q. So R12 bar is equal to the components, the two components are minus Z into AZ bar plus R into AR bar. And the base vector A R12 bar is R12 bar by the magnitude of R12. So magnitude is under root of the AZ coefficient and AR coefficient. R square plus Z square. And R into AR bar minus Z into AZ. Now in the numerator, to find the magnetic field intensity, we need the DL bar cross AR bar. So the H bar is equal to, the line integral, H bar is equal to, I told that it is I into DL bar cross AR bar. And similarly for the surface, I told that is a K bar cross AR bar. Volume integral is a J bar cross AR bar. So totally the numerator. So here it is a line integral because we are assuming a long straight conductor on the Z axis. So DL bar cross AR bar. DL bar cross AR bar. So we considered here it is a cylindrical coordinate system. AR, A5 and AZ bar. What is a DL? DL bar is equal to, see here, DL bar is equal to dz into AZ bar. What is the remaining R and the phi is a zeros. So R is a 0 and the phi is also the 0 and dz. DL bar is equal. And AR bar is equal to the base vector AR bar is equal to, see here, the two components are there. One is AR bar component and another one is AZ bar component. And there is no A5 component in the AR12 bar. Okay. So here AR bar, the R component, there is no any A5 component if it is a 0 here. And AZ bar, the coefficient is a minus Z, you can take the Z. Okay. Any function AR bar cross B bar is there, you can find the dead function. And denominator A square plus under root of R square plus Z square is also there. I am finding only the DL bar cross AR bar without keeping the under root of R square plus Z square. Now see, to find the debt of this function, AR bar, and you can find both are the zeros only. And you take this line, the 0 into Z bar and dz into 0 is the 0. Then take the A5 also, A5. The 0 into Z bar, it's a 0. And here the dz into R is a minus actually. For the second term also, you can take the minus. Okay, minus into minus is a plus. So A5 into R into dz. Similarly, the AZ bar is also all the terms is a 0. So what it matters? So DL bar cross AR bar is equal to R into dz A5 bar. R into dz A5 bar. While applying the cross product, the magnitude of R1 bar is neglected for convenience and must be considered the first of further calculations. The magnitude, see here the magnitude is there, under root of R square plus Z square is also there. To obtain the cross product, we are neglecting for our convenience and must be considered for the calculations. The next values, you have to substitute this one. I DL bar cross AR bar is equal to I is multiplied here, I R dz A5 bar, and the denominator there is a R square plus Z square is there. R square plus Z square. Got it, madam? Now the dH bar is equal to, according to the Biot's law, dH bar at the point 2 means the point is on the y-axis. Okay. I dl bar cross ER bar by 4 pi R square. What is IDL bar cross ER bar? We got IR dz IR dz A5 bar and under root of R square plus Z square is there. And what is the R12? R12, we got the magnitude of R12. The magnitude of R12 is under root of Z square plus R square. Okay. So under root of R square plus Z square and whole power whole square is 4 pi. Okay. And this is only the function of IDL bar cross AR bar. And 4 pi, the R12 is under root of R square plus Z square. And square term is there, you can keep the square. So IR dz A5 bar whole divided by 4 pi. And these two functions, the two to get cancelled. R square plus Z square whole power 1 by 2 and R square plus Z square whole power 1. So 1 by 2 plus 1. Bases are same, you can add the power. That is it, 3 pi. Okay, IR dz A5 whole divided by the 4 pi R square plus Z square whole power 3 pi. Got it, my students? And here, when you take the integral on both sides, H bar is equal to the integral of because it is with respect to the Z is there. Z is equal to varies from minus infinite to infinite. Z is equal to minus infinite to infinite. IR dz A5 bar by 4 pi into R square plus Z square whole power 3 pi. Okay. From this right angle triangle, suppose you have the right angle triangle, we can assume the theta is there. Opposite side is the R and adjacent side is the Z. When we consider the theta, so tan theta is equal. Opposite side is the Z and the R. So here they are assuming the theta is here. The theta, the distance from origin to the point 1 is the Z, and the distance from origin to the point 2 is R. So opposite side, the tan theta is equal to. Opposite side is a Z, and adjacent side is a R. So Z is equal to R tan theta from this right angle triangle. Okay. Z is equal to R tan theta. Z square is equal to R square tan square theta. Z square is equal to R square tan square theta. And here the dz is converted to the theta values. Z square, Z is equal to R tan theta means apply the derivative on both sides. Dz is equal to R into, not the tan theta, secant square theta. The tan theta derivative is secant square theta into dt. Okay, dz is equal to, now we can replace R secant square theta into dt. Now here the integral values of the Z, we are converting that values into the theta values. So change the Z as the theta. So when Z is equal to minus infinite, what is the theta value? So tan theta is equal to, we have the Z by R. What is the theta is equal to tan inverse Z by R. So what is the Z here? Minus infinite. Minus infinite means the tan inverse of minus theta is a minus tan theta and minus tan inverse infinite. It becomes of minus pi by. Okay. So when the Z is equal to minus infinite, the theta is a minus pi by 2. Similarly, the z is equal to plus theta, plus not the theta, plus infinite, the theta is equal to plus pi by 2. Okay. Now, you can substitute all the functions here. H bar is equal to, now the integral is changes as a theta value, where the theta is equal to minus, that is equal to minus infinite, the theta is a minus pi by 2. So pi by 2 here, and plus infinite is a pi by 2. Now, we change that, the I is a common term here, the R is there, the dz. What is the dz? We got the R secant square theta d theta. R secant square theta d theta. And in the numerator there is a phi is there. You can keep that a phi bar whole divided by 4 pi into, is a constant. R square is R square only. Now what is the z square here? See, the z square is equal to R square into tan square theta. Okay, R square plus R square tan square theta. Okay, now simplify this, h bar is equal to integral minus pi by 2 the pi by 2. I into R is R square secant square theta, and here the whole power 3 by 2 is also there. Secant square theta d theta, and a phi bar whole divided by 4 pi into, see the R square you can take as a common, whole power 3 by 2 is it, to get cancelled, R cube will get. And 1 plus tan square theta. 1 plus tan square theta is nothing but the secant square theta. 1 plus tan square theta, for the trigonometric function, 1 plus tan square theta is equal to secant square theta. And secant square theta is a whole power 3 by 2. So 2 to get cancelled becomes of secant cube theta. So secant cube theta. So here the R square is there, and you can cancel this one, and secant square theta and cancel. So what is the final value of h bar is equal to I. R square get cancelled, secant square is also get cancelled. I d theta a phi bar in the numerator, minus pi by 2 the pi by 2. And in the denominator, we have only the 4 pi R secant theta. Okay. The d theta is there. 4 pi R secant theta. What is a 1 pi secant theta? 1 by tan is a cot, 1 by secant is a cos, and 1 by cosecant is a sine. So secant theta, you can write the first of all secant theta. So here, with respect to the integral is a theta, the remaining all the functions is a constants. So write it is outside. I by 4 pi r. 4 pi r, a phi bar also is a constant. Now the integral minus pi by 2 the pi by 2. Cos theta into d theta. Okay, cos theta into d theta. Now we got that. See, cos theta into d theta, a phi bar also. What is the integral of cos? It is a sine theta. Integral of cos is a sine theta. So I into a phi bar whole divided by the 4 pi r, and is a sine theta. Upper limit is pi by 2. Lower limit is minus pi by 2. So sine pi by 2 is a 1. And second term, the lower limit is substituted. Sine of minus theta is a minus sine theta, and minus into minus is a plus. The total function is, you'll get the 2. So the H bar is equal to I into A5 bar whole divided by the sine theta I can substitute. It's a 2 is there. Finally, you'll get that 2 pi r. H bar is equal to I by 2 pi r into A5 bar. Okay. I by 2 pi r into A5 bar. I by 2 pi r into A5 bar amperes per meter. Rho L by the 2 pi epsilon naught r is a electric field intensity due to the infrared line charge. So we got H bar is equal to I by 2 pi r into A5 bar magnetic field intensity. The magnetic flux density B bar is equal to, the B bar is equal to mu into H bar. Mu into H bar. Okay, so mu I by 2 pi r into A5 bar. B bar is equal. And what is the electric field intensity? We already find out that is a rho L by 2 pi r epsilon naught into r is AR bar. Actually, it is a Y bar. We have to write it is a AR bar. So what is it? Magnetic, not magnetic, electric flux density rho L by the 2 pi r into AR. So we got electric field intensity and the electric flux density from the due to the infrared line charge. And for the magnetic field density, we got now the I by the 2 pi r, I by the 2 pi r. Simply say H bar is proportional to 1 by r and E bar is proportional to 1 by r. B bar is also proportional to 1 by. Okay. So here, mu I by the 4 pi r into A5 bar, it's a Weber per meter square. Weber per meter square. Got in my definition. And next one, H bar due to the tight conductor of a finite length. Previously find out the infinite length. Now we can find out the finite length. The finite length also we can assume on the z-axis only. On the z-axis only. What it matters, students? On the z-axis. So consider the conductor of a finite length placed along the z-axis as shown in the figure here. It carries a direct current I. The perpendicular distance of point P from the z-axis is r. Okay, the distance from the origin to the point P is r. The conductor is placed such that its one end is at the z1 and while other end is at the z2. Okay, in between the z1 and the z2, you can assume a differential length dl bar. Since it is on the z-axis, dl bar is equal to dz into az bar. dz into az bar. To find the p bar, there is a two components of there. One is the z into az bar is a downward direction, and the one is r into az bar. That is for the infinite length. Now it is a finite length from the point P to the Z. From point P to the Z, assume there is an alpha 2 at the angle, and point P to the differential length, assume it is an alpha, and the point P to the Z1, assume it is an angle with alpha 1. Okay, at Z1 alpha 1, Z2 is alpha 2, and at the point DL bar, nothing but the dz into az bar is a alpha angle. Previously, we assumed that is a theta, is a right angle triangle. Okay. Now, what is a A12 bar? The base vector A bar, the R12 bar is a R12 bar. Is a downward direction here. Minus az into az bar is a one component. and another one is a R into AR bar is another component to find it the P. So as usual, the same thing, minus Z is Z bar plus R into AR bar whole divided by Z square plus R square. R12 bar is equal. What it matters. And DL bar. What is the DL bar? As AR bar. Again, you can check the dead value to find DL bar cross AR bar. AR, A5, AZ bar. So DL bar as AR bar. So first of all, you can write the DL bar terms coefficients here. DL bar having only the Z, so 0, 0, DZ. And AR bar having the two components. So one is a R, and there is only phi, and we have only the minus Z. For our convenience, I'm not writing the denominator of under root of Z square plus R square. Okay, and AR bar, both the terms is a 0. AZ bar, all the terms is also the 0. Here the R is there. And we have only the A5 bar, that is a minus A5 bar, 0 into Z is a 0, minus R into BZ. So minus into minus is a plus, R BZ A5 bar, the cross product. So IDL bar cross AR bar, IR DZ A5 under top R square plus Z square, whatever we find the last, the infinite line, ideal bar cross AR bar is the same. The DH bar is equal to ideal bar cross AR bar under root of R square plus Z square whole power 3 by 2 is also the same. DH bar is equal. Up to this, whatever we find the previous infinite line charge or the straight long conductor is the same. Okay, my dear students. Now, for the infinite length, the given alpha angle and alpha 1 and alpha 2. So assume the right angle triangle. Okay. And Z axis, because it is a differential length, is on the Z axis. Alpha with an angle. Alpha is an angle here, not the R, alpha. So opposite side is a Z and adjacent side is a R. So tan alpha is equal to Z by R, and Z is equal to R tan alpha. R tan alpha. And Z square is equal to R square tan square alpha. But it matters. And now, because it is an infinite length, not the infinite, it's a finite length, for Z is equal to Z1, but Z is equal to Z1, and there is a Z1 is a alpha 1, and Z2 we can consider alpha 2. So Z1 is equal to, or we can assume that is a opposite side is a Z2. Z2 is equal to R tan alpha 1, because opposite side is a Z2 and the adjacent side is R for all the terms. And for the Z1 also, R tan is Z alpha 2 and it is alpha 1. Okay, my dear students. So alpha 1 is equal to, you get the tan inverse Z1 by R, and alpha 2 is equal to tan inverse Z2 by R. Okay. Now we can substitute the H bar is equal to Z1 to Z. Previously we assumed the minus alpha to the infinite, but here the finite length, one is a Z1, another one is a Z, another one is a Z2. So alpha 1 you can consider as a tan inverse and alpha 2 is a tan inverse, alpha 1 and alpha 2. Substitute all the terms in terms of the alpha only. I, R is there, and the dz. What is a dz? We got dz is equal to R into tan alpha, nothing but the secant square alpha into d alpha. Substitute the dz is R secant square alpha into dz. A5 bar is already there, and 4 pi R square plus R is equal to, what is R is equal to? Z is equal, not it is a Z square is equal to R square tan square alpha. And simplify this equation. I, numerator is R square secant square theta, and the denominator also, take the common of R square, you get the R cube, and 1 plus tan square theta is the secant square theta, and whole power 3 by 2 becomes of secant cube theta. So in the numerator, R square secant square alpha is get cancelled, and we have only the denominator is R secant alpha. Okay, I by 4 pi R is a constant, and cos alpha d alpha into a pi. Previously, this function is a minus pi by 2 to the pi by 2. Now it is alpha 1 to the alpha 2. Sin alpha 1 by the sin alpha 2. Got it, my students? What is alpha 1? Alpha 1 is equal to tan inverse Z1 by R, and alpha 2 is equal to tan inverse Z2 by R. So directly you can substitute and say H bar is equal to I by 4 pi R sin alpha 2 minus sin alpha 1. That you can substitute alpha 1 is equal to tan inverse Z1 by R. Or B bar is equal to mu into H bar mu I by the 4 pi R sin alpha 2 minus sin alpha 1 into A pi. Only the difference is previously we got H bar is equal to I by 4 pi R sin alpha, or the sin alpha sin theta pi by 2 minus pi by 2, as it is an infinite long straight conductor. Infinite function. For a finite function, the H bar is equal to the same thing, I by 4 pi R and sin theta, but the limitations is for alpha 2 and alpha 1. After the simplification, we got this H bar is equal to sin pi by 2 is a 1, sin pi by 2 is a 1, and sin of minus pi by 2 is a minus 1, minus of minus is a plus, we'll get the 2 here. So after that, H is equal to H bar is equal to 2 pi R into A pi bar. Infinite like. Now, it is in the form of a sin alpha 1 and alpha 2 4 pi R becomes of sin alpha 2 minus sin alpha 1. H bar is equal. It is also the A pi bar. What is alpha 1? It's tan inverse Z1 by R, and alpha 2 is a tan inverse Z by Z2 by R. Okay. This is H bar due to the finite length. If both ends of the conductor are above the point P, then alpha 1 and alpha 2 are positive. If both the ends of the conductor are below the point P, then the both alpha 1 and alpha 2 are the negatives. So we assume the alpha 1 and alpha 2 the points on the positive z axis. If it is below, it is a negative axis. See, the 1 and the 2 is in the positive. When we consider the 1 and the 2 on the negative z axis, the alpha 1 and alpha 2 are the negative. While if one end of the conductor is above the point P and below the alpha 1, so alpha 1 is a negative and alpha 2 is a positive. It depends. depends. It depends upon the taking of the finite values. So we assume that 2 and 1 is on the positive axis, both are the alpha 1 and alpha 2 is a positive. And if you consider in the below, it is a both are on negative. If you consider 1 is on the positive and 1 is on the negative, means whichever it is on the positive, that is a positive value. Whichever the angle is there in the negative, that is a negative angle. Okay. So finally, the magnitude of H bar is I by 4 pi r sine alpha 2 minus sine alpha 1. Okay. But the direction is always a normal to the plane containing the source and to be decided the right angle screw rule. Right-handed screw rule. Right hand thumb rule depends. Okay. And into A5 bar is also there because H bar cannot be in the A5 bar. It depends on which the plane is segmented carrying the current is placed. It is a depends. But we got here it is a A5 bar only. You can put that it is a A5 bar or AN bar. It's a AN bar. Without confusion, we got with the A5 means which bar is a A5 on. Got it, got it. Then you go for the third one. The third one, there is no any electric field intensity due to the finite length. In the magnetic field intensity only we have that H bar is equal to H bar due to the finite length. But H bar at the center of circular conductor, there is electric field intensity due to the circular loop. Okay. Now the third one is H bar due to the center of circular conductor. Previously, if I find that a current carrying conductor, a long straight conductor, now it is the same that long straight conductor is the circuit. H bar is at the center of the circular loop, is to be obtained. The conductor carries a current, direct current I. A small differential length, it is also the differential length or not, it is a differential phi or something. Because the same straight long conductor, now you can place that as a circuit. Okay, the direction of DL bar at the point 1 is a tangential to the circular conductor at point 1, where it is a theta angle between IDL bar cross AR bar is. AR bar is a unit vector, R bar is a distance vector joining the differential currents. Now, IDL bar cross AR bar is a I. We know the cross product is a magnitude of the function into sine theta. So, IDL bar the magnitude and the magnitude of AR bar and sine theta AN bar. Previously is a infinite straight conductor. We can take the differential length is on the z axis. DL bar is equal to dz into AZ bar. Now it is a circle. The theta is an angle there at the DL bar to the point P. So the IDL bar cross AR bar becomes I with the magnitude of DL and the magnitude of AR and sine theta AN. Okay. So DH bar is equal to IDL bar cross AR bar by 4 pi r square is the magnetic field intensity due to the line charge. Now the DL bar cross AR bar becomes DL sine theta AN bar. DL sine theta. What about the AN bar is a unity one. Unit circle. The value is a 1. So IDL sine theta AN bar by 4 pi r square. Why I have taken the R is R12 is a radius one. The H bar is equal to the line integral IDL sine theta AN bar by the 4 pi r square. The integral is a line integral DL. The circumference of the circle now. The integral of the DL we can take it as the circumference of the circle. Circumference of circle is 2 pi r. You can substitute find out the magnetic field intensity H bar. H bar is equal to I sine theta 2 pi r is a total integral of DL. Integral of the DL is 2 pi r. So 2 pi r into a n bar, 2 pi and 4 pi will get cancelled, having the 2 I sine theta, and r is also there here. R and R get cancelled, 2r. H bar is equal to I sine theta by the 2r. Okay, my dear students. And since IDL bar is a tangential to the circle with the radius R12 is the radius, so the angle must be the 90 degrees. So 90 sine 90 is a 1. So H bar is equal to I by the 2 pi r. And magnetic field intensity due to the circular loop, magnetic field intensity due to the circular loop, H bar is equal to I by the 2 pi 2r only, under 2 pi r into a n bar. Okay, since the theta is a 90 degrees. So actually it is a I sine theta by. Got it, my dear students? And the B bar is equal to mu naught I by 2r into a n bar Weber per meter square. And here the a n bar. Got it, my dear students?